Let's learn the 4 categories for furnaces and appliances. Now, my favorite book is the International Fuel Gas Code. Chapter 5 is a good chapter. The code puts furnaces in 4 categories based upon flue vent pressures, flue gas temperatures, relating to whether it condenses or doesn't condense, and vent pipe materials. And we have a table here. Let's take a look at the table a little bit closer. So at the top, we have the pressure of the flue, negative or positive. And on the left side, is it condensing or not condensing? In category 1, top left corner, is an appliance that operates a non-positive vent static pressure with a vent gas temperature that avoids excessive condensate production in the vent. It's hot. Category 2, not really common for residential. An appliance that operates with a non-positive vent static pressure, non-positive, and with a vent gas temperature that can cause excessive condensate production in the vent. Category 3, an appliance that operates with a positive vent static pressure and with a vent gas temperature that avoids excessive condensate production in the vent. Category 4, vented appliance, that's pretty common for us home inspectors to find. And it's both in that bottom right corner, so we have a flue positive pressure and it's condensing. And a category 4 vented appliance is an appliance that operates with a positive vent static pressure and with a vent gas temperature that's cool that can cause excessive condensate production in the vent. So that furnace is going to collect and discharge that condensate. So Chapter 5 of the International Fuel Gas Code identifies 4 categories for combustion furnaces and water heaters based upon combustion type, sealed or unsealed, vent pressure, and vent pipe temperature. A common vent flue pipe material for category 1 is B-vent or type B. And for category 2, it's going to be a specialized kind of thing by the manufacturer. Category 3 may be stainless steel. And a common pipe material for category 4 is going to be PVC or CPVC. Type B vents are designed for venting non-condensing gas appliances equipped with a draft hood and fan-assisted appliances that operate with a non-positive vent pressure. A type B vent must never be installed on a category 3 or 4 gas-fired furnace appliance. Type B, BW, that's the oval one, and L are designed for natural draft applications only, and they must not be used for vents under positive pressure. Carbon monoxide will just come through the pipes. It'll be hazardous. Okay, so we have a little illustration of a category 1 here. And a category 1 furnace operates with the flue at a neutral pressure or negative pressure with respect to the combustion appliance zone. Combustion appliance zone. That's like the furnace room. It's a CAZ. C-A-Z, CAZ. That's the room in which the furnace is located. And the stack temperature is hot enough to avoid condensate in this vent in a category 1. The burner draws its combustion air from the CAZ, the combustion appliance zone. The combustion chamber is also open to the CAZ. For example, if you're standing next to the furnace, you should be able to look in and see the burner and the flames. Older category 1 furnaces use an open draft hood that allows dilution air to enter the vent pipe and mix with exhaust gases. They don't make them anymore. A draft diverter at the base of the flue protects the flames from downward drafts coming down the chimney or flue. These older furnaces are not mechanically drafted, but are called natural draft or atmospheric draft because they rely entirely on high flue temperatures relative to the outside temperatures to draw exhaust gases up and out of the flue. Because so much of the heat goes up the chimney, they really waste a lot of energy. Natural draft furnaces have very low annual fuel utilization efficiency ratings. That's the AFUE, usually less than 72%. Really low efficiency, they don't make them anymore. If you see one, it's probably on its last legs. Newer type of category 1 furnace replace the draft hood with a small fan, referred to as an induced draft fan, which pulls air through the combustion chamber, although the furnace still relies on flue temperatures to lift the combustion gases up the flue stack. The induced draft fan helps to prevent backdrafting on startup and assists in getting the draft started. Once the vent pipe gets to a certain temperature, over greater than 140 degrees Fahrenheit, and the draft is established, the pressure inside the vent pipe becomes negative with respect to the CAS. Depending on the model, the induced draft fan may turn off, but will continue to spin due to airflow. Category 1 furnaces that incorporate an induced draft fan typically have cleaner and more complete combustion than the older counterparts and therefore expel less pollutants into the air. The byproducts of an 80% plus furnace are CO2, carbon dioxide, nitrogen, and water. Category 1 induced draft furnaces typically have efficiencies around 80 to 82%. And here's an illustration of a Category 1 with a draft inducer fan. You can see the draft assisting fan is on the left side. It's connected to the exhaust vent pipe. Mid-efficiency furnaces, 80, 82%, use fan-assisted combustion systems to pull flue gases through the heat exchanger. No dilution air is required for the vent system, which is still buoyancy driven. An induced draft fan equipped furnace is considered a mechanically drafted furnace, according to the International Mechanical Code, IMC. However, because it relies on negative flue pressure to carry away combustion products, it can, like the naturally drafted furnace, have the potential to backdraft. And backdrafting, when combustion gases spill down into the CAS rather than going out the flue, can occur if the CAS becomes depressurized with respect to the flue. This could occur if multiple exhaust fans and the dryer, the clothes dryer, or the fireplace are all operating at the same time. So, remember, Category 1, negative or neutral vent pressure, non-condensing, high temperatures, the draft hood or integral vent blower or draft inducer fan assisted. Category 2, furnace or appliance. Category 2 applies to some commercial furnaces and not commonly for residential furnaces except for some boilers and wall-vented water heaters. Category 2 also operate under negative or neutral vent pressure. Condensation of the flue gases could occur. Vent systems have special provisions from the manufacturer. Category 3. Many Category 3 furnaces are high-efficiency oil furnaces with a gun-type burner that force fuel oil through a nozzle. It mystifies it and ignites it and for a more efficient burn. And these oil furnaces have a mid-efficiency or higher, 82 to 88%. Category 3 could also be a tankless water heater that vents using stainless steel pipe material. Category 3 furnace has a vent pipe that is under positive pressure and the furnace is non-condensing, meaning its flue gases only go through one heat exchanger and then exit through the vent at temperatures above 140 degrees Fahrenheit. The appliance could produce condensation, although they are not considered to be condensing appliances. Let's go to Category 4. Category 4 furnaces are combustion appliances that have a vent pipe under positive pressure and flue gases under 140 degrees Fahrenheit. So positive pressure in the pipe and low temperatures. The vent exhaust is so low because all Category 4 appliances are equipped with a secondary heat exchanger, and that heat exchanger further extracts from the combustion air as the water vapor, a byproduct of combustion, cools and condenses into liquid water. And then this liquid is drained to the outside through a condensate drain, usually a collection pump. The condensate is highly acidic, so local code may require it to be pre-treated before disposing into the sewer. Because the combustion gases are directly through a secondary heat exchanger, more heat is extracted, enabling a gas-fired Category 4 furnace to achieve efficiencies greater than 90%. Only 10% of energy is wasted. Category 4 oil-fired furnaces can achieve efficiencies of 95%. Category 4 furnaces with two-stage motors for high and low capacity can achieve even greater than 94%. So positive vent pressure, condensing flue gases, and you need a method of collecting and draining the condensation. And there is a little drawing of a Category 4 furnace. High efficiency, 90 to 98% furnaces add a secondary heat exchanger to pull more heat out of the exhaust vapor and then vent emissions directly outside, eliminating the risk of backdrafting flue gases into the home. There are also Category 4 water heaters that vent using plastic pipe, PVC or CPVC. Like Category 3 furnaces, Category 4 furnaces are forced draft, meaning they are equipped with a fan to pull air through the combustion chamber and push the byproducts of combustion out of the furnace through a vent pipe, and the vent pipe is sealed so that they cannot backdraft. Category 4 furnaces should be installed as sealed combustion direct vent appliances, which means their combustion chamber is sealed off from the CAS, and they draw their combustion air from the outside through a second pipe that brings combustion air directly into the combustion chamber from the outside of the home. Because nearly all of the heat in the combustion gases is removed by the two exchangers, the two heat exchangers, the vent pipe is made out of plastic. Manufacturers do not recommend installing Category 4 furnaces as non-direct vent furnaces that draw their combustion air from the compliance zone. Always install the second vent pipe to bring combustion air from the outside right into the combustion chamber. It's an all-sealed chamber. So I hope those tips were helpful for you to understand about the 4 furnace categories.